Hello, we're here at the Big Science Forum 2018 at the stand of CNIM from France with Jean-Claude Cercassi. What do you produce and how does that fit into Big Science?
So basically we are producing we have two kind of activities. We are providing build-to-print components. As you can see on the screen, we have built the radial plate of the toroidal field coils of ITER. That's a big activity for us. We are producing for the time being the prototype of the diverter cassette body, pre-compression rings, composite materials, so various manufacturing activities. And on the other hand, we're also involved in the design and build of complex systems, especially remote handling systems. So basically we are working on manufacturing and complex systems.
I didn't get the second one. The first one you spoke about the toroidal rings for the ITER.
Yes, that's it.
And first, let's start with that. These are the rings. How does that work in the tokamak machine?
So the rings are called radial plate. The radial plate is supporting the superconducting cable. It's a D-shaped component, 14 meters long, 10 meters wide, large. And there are 7 plates per toroidal field coils. We have delivered 70 radial plates together with an Italian partner. And it's a very specific manufacturing route because we had to develop specific processes such as local vacuum electron beam welding. So we have an expertise in EB welding, but local vacuum is quite new, so we have developed this specific application for the radial plate project. Local vacuum means that instead of, the classical way is to fit the parts to be welded inside a large vacuum chamber. In the present case, the parts are too large, so we have developed a local vacuum chamber. We just fit on the joints where we want to weld. So that's a benefit of the ITER project to our company. It's an example of the technology we have made the acquisition for ITER.
And this has to do with the creating the magnetic field to enclose the plasma.
Yes, the radial plate is a component inside the TF coils. So in the ITER system, inside the magnet system, there will be some components from CNIM, as you can see on the picture. On screen.
And then you said that you're also involved in another area. What was that again?
Yes, basically we started with ITER 10 years ago and we have nearly 10 ongoing contracts. Radial plate is over now, it's completed. We have delivered the last one last year. Now we're working on the diverter cassette body prototype phase for the time being. We expect to be involved in serial fabrication. We're working also...
What is that?
The diverter is an in-vessel component inside the tokamak. The tokamak vessel is the lower part of the tokamak, which receive a very high neutronic flux. So the diverter has to withstand this high heat load. And for this purpose, there are tungsten components on the diverter, and there's a supporting frame, what we call cassette body, which supports the tungsten tiles. And it's a very specific shape, as you can see. It's the white mock-up here. Sorry. So this is a mock-up of the cassette body. It's 1/10 scale. So if you visit our facility right now, you will see for real the diverter cassette body. It's a stainless steel component and merging various kinds of welding process. Narrow gap TIG welding, electron beam welding, and a lot of machining steps as well. So This is really the main skill of CNIM, my company, to set up all these manufacturing routes and implement specific processes, especially on welding and machining.
And then you also say on your wall here, you speak about space, astronomy. What do you have to do with space?
Well, for space, CNIM is a group, and inside the group there are various entities, and one of our subsidiary, 100% subsidiary, is Bertin. Bertin is a CNIM subsidiary, and they are dealing with space, ground support equipment. And we have also another subsidiary, Winlight, dealing with very high performance optical components. So they are mainly involved in the space activity more than the factory dealing with ITER.
Okay, and I like your slogan. You say, "You imagine, we create." That as the theme of this conference, the interchange between big science and industry, where in that slogan you're saying that the scientists come up with ideas, and then it's the industry,
yes,
high technological industry, that has to figure out how to actually make them in the physical world.
Yeah, you're right. And in ITER, there's a lot of scientists coming from all around the world with their idea of scientist ideas. And we are engineers, and we are here to make this idea for real. So we are providing manufacturing engineering, industrialization, and that's also one of the skills of CNIM, to be able to translate from conceptual design based on scientists to industrial design.
And just the last thing, how did it work in terms of your working with ITER? Did you have this capability already worked out before they came around, or did you say, okay, how can we fit in, and did you develop things new specifically for the ITER program?
Well, we're working on the big science market for nearly 20 years. And we really started with a French government project called LMJ, Laser Megajoule, which is a laser fusion project. So we've been involved in the LMJ project in the early 2000 years, and dealing with a large turnkey contract where we have to provide a conceptual design, detailed design, manufacturing, installation of process equipment, robotics, remote handling systems, and it was really the beginning of our big science business, which is now quite important at CNIM. And when ITER started in 2007, we were interested in working for ITER, so we've been present from the very beginning, and now we are quite happy because we are running several contracts, and there's still some work ahead for us, especially related to the site works. We are lucky because we are based very close to ITER in the south of France, so we are now looking for tokamak assembly site works.
But, for example, what you explained about machining this toroidal D shape, was that something that you had? Did you have the technology already before ITER, or did you make something new, special as a result of wanting to work with ITER?
We have a very strong manufacturing engineering team, and we have a large range of machining units, machining centers. However, for ITER, we have to start from the scratch because the milling machine you've seen on the screen doesn't exist. Well, did not exist before, so we have to think about the specification of this new tool, procure it, install it, qualify it, and the requirement in terms of tolerances, for instance, was very high, very demanding. Even the schedule was very tight. So the milling machine, the electron beam welding machine, and some of the tooling we have developed for the manufacturing work are really specific to ITER, and so we had to work out the routes and the layout of the workshop. We have built a new workshop for this project. With a temperature control area where the large component can be machined without any distortion due to temperature. So it was really a very important project for us, and we have invested a lot, and I would say that we have also gained a lot from this project.
Thank you very much. It's very instructive.
You're welcome.